All right, the last thing that we're going to talk about for right now is some students have been curious and are not sure how to decompose numbers like this, okay? We said we had to take it from the 10, right? So we put 10 down here, and then we look at it and go, oh my goodness, what do we do? Well, you always have to think that you want both of these numbers to add up to whatever number is at the top. But what do? Because that's a big number. 70 is a big number, right? Well, how do you know what goes in there? Well, I've told students that have had some troubles with this, you really have to think about this number bond as a number bond that actually looks like this. And my question would be, well, what would you put in there? 1 plus what gives you 7? And of course, the answer everyone says is, well, it's 6. So 6 plus 1 is going to give you 7. Well, this is exactly what this is. If you cover up the ones place, right, you have a 7. You have a 1. So these numbers are really the same as these. The only difference is that you are using multiples of 10. You are changing how many 10s you have. So, for example, you would just put that there. 60 plus 10 is going to give you 70. Or, if you take away all of the 10s and you just leave yourself with 1s, you'll see that 6 plus 1 equals 7. So it's not as tricky as you actually are thinking, first graders. Let's give you another one. Alright, so let's say we wanted to do 50, right? And we want to take and break down, decompose. We want to take from our 10, so we know that we need to put our 10 in there in order to subtract whatever we're going to subtract. But what are we going to put in this circle here to make it this number plus this number is going to equal 50? Well, imagine that you were taking away the zeros, you're covering them up, and you're just dealing with ones place numbers, one-digit numbers, right? So you got a 5, you got a 1. What plus 1 is going to give you 5? Well, we know that answer. It's 4, right? So that's exactly what it is here, except that you are using the 4s now in the 10s place and the zeros in the 1s place. So there have been problems also that have asked students to design their own. For example, let's say 40 minus 2 equals what? Okay. And the homework has asked you to create a problem that is similar to that. Okay, well, count by 10s, or count up or down by 10s. Let's see. 30 minus 2 could work. 70 minus 2 could work. 80 minus 2 could work. 10 minus 2 could work. So if you take a look at what they all have in common, we know that we're all taking away the same number, which is 2. Okay? There's zeros in the ones place. And you're just changing the amount of 10s that you have. So it's not as complicated as I think some of us were trying to make it. You can do the same thing with other numbers too. So if you have a number, let's say a 27 minus 5, right? And you were asked to create a number sentence that was similar to that using a basic fact like that. Well, you can use 37 minus 5, you can use 87 minus 5, you can use 67 minus 5, 17 minus 5, right? They're really close. Let's see what they have in common. Well, we're always taking away 5, and there's a 7 in the ones place, and the only thing that's changing about these numbers are how many numbers we have in the tens place, how many tens we have. So it's not as tricky as I think we tried to make it for ourselves.